presentation today is on rotary actuators, and I'm Liam Schilder.
My name is Pascal Baumann. Let's begin.
First type of rotary actuator is a type of electric actuator known as a stepper motor, which is a type of motor that divides the full rotation into a number of equal steps. This motor can then be commanded to stop at any one of these steps without the need for a position sensor. It then converts a series of input pulses into a precisely defined increment in the shaft position, and each pulse moves the shaft at an exact angle. So, stepper motors have electromagnets attached around the central gear. The electromagnets are energized by an external driver circuit, microcontroller, and to make the motor shaft turn. One electromagnet is given power, which magnetically tracks the teeth slightly, and it offsets them from the rest of the teeth. This means that when the next electromagnet is turned on and the first is turned off, it rotates slightly, basically. And there the process is repeated, and you get each rotation is called a step, and specified number of steps makes a full rotation. Yeah. And some of the advantages of this kind of motor over others are that it's more durable, it's cheaper, it's pretty reliable, and it is high torque when it starts up and on low speeds.
So another type of electric actuator is a servo motor. So they're common in robotics and manufacturing institutions. And the type of system that these motors use is called a closed loop system. So it's basically a motor that's joined with sensors, unlike the stepper motor. This one has sensors, and it reads information on the position of the rotary movement, which will then affect the movement. They can also produce linear movement as well as rotary movement. They're a more high-end choice than stepper motors because, well, they have the sensors, and they give more feedback, and they allow for more precision work. A cheaper, simpler servo motor uses a potentiometer as an encoder, while newer ones will use rotary encoders. And a newer type of electric actuator will sometimes include a memory wire, which basically heats up, changes shape, and then it'll affect the output, and then it'll return back to its original shape once the current is absent.
So then we have fluid and vacuum power actuators. The first type, fluid power actuators, both hydraulic and pneumatics are considered fluid power actuators, even though a pneumatic is technically gas. But they usually drive the larger, more powerful actuators. But since their internal construction is pretty similar, they're considered together. They usually have two forms. Those where a linear piston cylinder mechanism is geared to produce rotation, and those where a rotating asymmetrical vane swings through a cylinder at two different radii. Different pressure between the two sides of the vane makes an unbalanced force, and thus a torque in the output shaft, which doesn't rotate. Vane actuators require a number of sliding seals, and the joints between these seals tend to cause a lot of problems. Leakage, and for the piston cylinder type, which is a lot more simple and basically blunt.
And then a vacuum actuator, they're mostly found in automobiles, and they're not as common these days, but they consist basically of a vacuum chamber, a piston, and an actuator rod, and once air leaves the chamber, the piston will move, and that'll also move the actuator rod.
Any questions?
What is a rotor?
A rotor is basically something that moves in a circle, essentially.
Yeah.
It's a type of
circular motion.
Circular motion. Anything else?
Any other questions?